any arbitrary execution environment can be made to run on rollups, and essentially what these rollups are hungry for, right? Like on the base layer, like what do they depend? Like right now, they're almost all implemented on Ethereum, but what are they most hungry for is data availability.
And Avail is really coming in and really scaling that core data availability piece while allowing the flexibility for different layer twos built on top of it.
Around 70 to 90% of the rollup cost today is on, primarily on, like storing transaction data on Ethereum.
Well, Anurag, thank you so much for joining me. Really appreciate your time today. Looking forward to the conversation and really what you're building at Avail. I think the conversation has really centered, predominantly, I would say this year around really the traction that layer twos are ultimately getting, especially with the announcement of Base. There's a lot of kind of exciting news in the air, and I think what you're building at Avail ultimately helps accelerate that adoption. So really looking forward to diving deeper in one, to the technology stack, but two, kind of how you're viewing the industry as a whole as well. There's also lots of various debates around integrated versus modular chains, which we can get into. But again, super excited for you to be joining me on the podcast and looking forward to the conversation.
Yeah. Thanks for having me, and looking forward to the discussion.
Awesome. Well, maybe just, I think in general, probably people are relatively aware of Avail and what you're ultimately building there. But I would like to maybe start out the conversation by diving a little bit deeper into kind of the core problem that I feel like you are addressing, which is creating that unified data availability layer and really the role of data availability layers within blockchains. I think it would kind of be a great kind of foundation point for us and also the audience to really establish the role of data availability layers and what they play in blockchains, and then we can build from there.
I think that's a good start. In general, to give some context, right? You mentioned Base, but in general, the last 2-3 years, we've seen the rise of rollups in general, right? Like, so if you look at an Arbitrum, Optimism, this year's, like ZK, Polygon, ZK EVM, ZK Sync, for example, Starkware has been building rollup for quite some time. And then there is a lot of new teams that are building, like non-EVM rollups as well, right? And both in the optimistic and validity proof category, right? Like, so some of these, like I mentioned a little bit before, like Stacker is building a very specific kind of a stack. Fluent just, like the new startup that just announced, for example, which is building a ZK Wasm kind of environment. There are other startups like Blockless, which is again offering a Wasm kind of an environment. Risk Zero, like is building up, like a Risk 5 kind of a ZKVM and Prover, for example. And so, I mean, what is really happening is that over the last 2 to 3 years, especially on Ethereum land, what is happening is this whole rise of rollups, right? Like, and you see, like Arbitrum, pretty big in terms of TVL, and Optimism also not that far behind. And a lot of the newer rollups also catching up. ZK Sync, for example, ZKVM also taking significant strides, for example. And so in general, what has been happening is this rise of rollups. And so, like when I founded Matic or Polygon back in 2017, we were working on this. We started off as a Plasma solution on top of Ethereum, right? Like, and so if you look at Plasma, right, like it's a off-chain execution and off-chain data availability kind of solution. Of course, we never got to implementing Plasma because it was unworkable. But then finally, like we pivoted to rollups in general. So, I mean, rollups is a very particularly clever way of putting execution off chain, right? Like, I mean, and so you can see that already happening on Ethereum rollups, and it doesn't necessarily need to be EVM rollups, right? It can be like any environment. It could be even the Solana virtual machine, for example, or like any arbitrary execution environment can be made to run on rollups, and essentially what these rollups are hungry for, right? Like on the base layer, like what do they depend? Like right now, they almost all implemented on Ethereum, but what are they most hungry for is data availability. And for now, these rollups rely on Ethereum for data availability, and Ethereum never started off focusing on like data availability. It was like execution focus. It was one of the first chains. It was the first chain for general purpose computing. And so, in general, of course, it's become so big now. It's very difficult to like change it pretty quickly, right? Like so, it's taking its own sweet time, which it should, to kind of upgrade itself to a data availability layer. So you must have heard of proto-dank sharding and dank sharding. And so those are all upgrades to data availability, right? Like how can we provide more scalable data availability on the base layer, on Ethereum, for example, so that there can be more rollups that can consume this, like with more DA and less DA cost, right? Like just for context, around 70 to 90% of the rollup cost today is on primarily on like storing transaction data on Ethereum, right? Like that's a significant cost. Of
Yeah.
course, like they're working on proto-dash sharding, which should hopefully come up this year or maybe early next year, which will reduce cost by factor of like 1/5, 1/10. It'll depend. And so that will improve things, but essentially, like they will have to implement dank sharding, which will take a few years. But essentially, what I want to kind of wrap this discussion in this is that rollups are like particularly clever way of putting execution off chain. Right now, like they depend on Ethereum for DA, for example. I mean, it's not necessarily that rollups can run only on Ethereum. They can be run on any any chain as such, right? Like, and that's why like give a talk at Modular Summit in Paris a few weeks back, and I put out this slide saying every base layer blockchain is going to be a D layer. Like so. Base layers is like where DA will be optimized for and execution will be optimized for in the rollups. So that's
So maybe
yeah.
let me like break it apart a little bit or kind of rearticulate kind of your core thoughts, and please correct me if I get anything wrong. Ultimately, in blockchains, there's two main components that go into scaling. One is the data availability layer, and then the second one is compute. And that compute today can kind of either happen on the base chain that's kind of integrated with the data availability layer, or it can be separated and pushed to a layer 2 for an execution environment, and that lives out there. But the more that you kind of scale execution, the more hungry ultimately, or the more data that you actually need at the base layer to scale. So if you scale one, you also only kind of have to scale the other. And what Avail is ultimately doing, and kind of the modular roadmap, is separating the compute from the data availability bandwidth and scaling. Ethereum's kind of taken I'd say, conservative path for data availability, just as it was the first blockchain, and as the roadmap has kind of evolved, so has Ethereum. And Avail is really coming in and really scaling that core data availability piece while allowing the flexibility for different layer 2s built on top of it.
Absolutely, I agree. I mean, in general, I mean, I just like a response to, I think, one question you didn't ask directly, but let me answer that. Is basically you can scale DA on any chain, right? Like, I mean, any base layer, like DA, like what is data availability, right? Like, I mean, it's basically you have a set of transactions, you have to order it in some manner, and you have to keep it available so that like it can be verified. The execution can be verified against it, right? Like, I mean, now you can do it on any POS chain, right? Like any POS chain. It can happen on Ethereum, it can happen on Solana, like it can happen on any chain, right? Like, but essentially, what we are doing at Avail is basically a very different way of verifying it efficiently, right? Like we implement something called data availability sampling, which is this unique way for like very resource constrained light clients to verify the data availability component quickly and scalably, right? Like, I mean, you can do it on Ethereum today. You have to run a full node for that. You have to download all the blocks. You can do it in Solana today. You have to download all the blocks, right? Like, I mean, and what the main difference is, if we want like this DA, like block sizes that keep DA like to big numbers, right? Like, I mean, it's basically a block size scaling debate, right? Like, which is very different from the execution plus DA block size scaling debate. Like, you in DA, because we specialize on that, right? Like, we are able to scale block sizes pretty much, like to a very large amount, while still keeping the verifiability intact, right? Like, I mean, we're starting off with a block time of like 20 seconds. And light clients, we benchmark like sizes of 128 MB for the block size. And light clients still are able to verify well within the bounds, right? Like, I mean, and we are able to scale more, right? Like, that is very difficult to do in a chain that has both execution and DA. Of course, like see, everything is a trade-off, right? Like, I mean, I will not say, yeah.
Yeah. No, and to your point, I think data availability sampling is really novel. And as you mentioned, by allowing less resource compute and also ultimately bandwidth as well to verify the chains in kind of being able to verify the chain by having less resources, by having less bandwidth, and getting almost similar assumptions and trust to full nodes without actually having to run like a beefier full node and larger hardware is extremely novel. I'm very curious over the long term. I know Celestia was kind of one of the pioneers in this regard, and more blockchains are kind of taking this data availability sampling approach. Because to your point, I think over the long term, it's going to be very hard to actually fight the physics of like, you have to increase the bandwidth, you have to increase the compute. And if that is true, you have to figure out ultimately how to keep the verifiability, the property that we really love and enjoy about blockchains, to small resources. And that data availability sampling is a true unlock, I think, within the industry that allows us to do that. And it's amazing to hear that the Avail team is also working on data availability sampling. One thing that you mentioned, though, is kind of around, I would say, the larger conversation of like integrated versus modular chains, and the fact that your belief that all chains will really need kind of layer twos down the line. Can you maybe expand upon that? Because I think this is like a fierce debate that's kind of happening on Twitter and within our communities at the moment.
Yeah. I mean, so as I said, right, like, it's always, there are two sides to this debate and there are always trade-offs, right? Like, so, but I'll just come up with my viewpoint, right? Like, so essentially, I think some of the discourse that I've seen on Twitter and on, in general, right? Like, there's this notion that modular systems are not integrated, in general, right? So monolithic chain, for example, I mean, it's all tightly coupled, everything. So the definition or the usage of the term modular is, taken a little bit of the, liberty in some discussions, right? Like, I mean, so being modular does not really always mean not integrated, right? Like, I mean, so for example, I'll give you an example, right? Like, so, like someone, a user who's running like a rollup, or who's using a rollup on Ethereum, let's say Arbitrum, for example, or some other rollup, right? Like they don't really care about, the how many modules are in this rollup that is working, right? Like, I mean, most users don't even care whether, this rollup settles to Ethereum, for example. I mean, some rollups don't even have working fraud proofs in production, for example. In general, so the experience of a user, right, like on, let's say, Arbitrum or Polygon ZK EVM is not very different from, let's say, a user on Ethereum or Solana, for example, right? Like, I'm talking about the base execution layer, right? Like, I mean, the way they send the transactions is, let's say, is almost the same. There might be on ramps, off ramps, exchange connections, for example. I mean, there is a bridge from a roll up to Ethereum, but like the bridge to Ethereum is like just like a bridge to another blockchain, right? Like, I mean, of course, under the hood, it is trust minimized and all that, right? Like, but every blockchain like has that experience. So I mean, I think it's a little bit intellectually not that honest to say that modular systems are not integrated in that sense, right? Or provide like a incoherent user experience. In general, what modularity does is it basically focuses on component specialization, right? Like now, once these mature enough, right? Like I mean, we are still very much in the early stages of modularity in blockchain, right? Like I mean, that data already sampling layers are just now getting into production, for example. Roll-up technology is also just about getting, like it's not. I mean, we have like an optimistic roll-ups running for 2-3 years, but GK roll-ups are pretty new. And all of these newer roll-ups will take some time, right? Like so, and there's a lot of abstraction and middleware yet to be built in the modular ecosystem, right? Like so, it's not the right lens to directly compare what a monolithic blockchain can do with the state of the modular ecosystem today, right? Like, I mean, it will change in the next 6, 12, 18 months in general, but I mean, yeah, hopefully, like that provided some context.
100%. And I think, honestly, a lot of the confusion ultimately lies, in my belief, around modular versus kind of the integrated stack, and that one is more inherently scalable than the other. I think both of them, if given the same kind of data availability layer, whether it's integrated on the base layer or kind of separated via a layer 2 and have the same compute and the same data availability, ultimately they have the same scalability properties. And I think the fact people sometimes confuse that, one ecosystem is inherently more scalable than the other, and that's leads to a lot of confusion on the timeline.
Yeah, I mean, of course. I mean, so when I see some debates, right? Like, I mean, so see, debates are good. I mean, they help further the industry forward. But essentially, the points of debate should also be, like pretty clear, right? Like, I mean, I think one, like, let's say, let's have this, let's say this critique that, there's a lot of new infrastructure that app developers have to maintain, when they do, let's say, app change on modular infra, right? Like, I mean, that's right. That's at the moment, right? Like, I mean, it's currently, like, let's say, it's a base example, right? Like, the OP stack is open source, and like Base or Coinbase took the OP stack and like spun up a new rollup, and now they have to kind of maintain that all that, for example, for now. But like as we move ahead 6 months, 12 months, like we already seeing like rollup as a service providers gaining prominence, for example, and like there's a lot of abstraction that happens. See, the beauty of a rollup, especially like a like an optimistic rollup, is it massively lowers the cost of spinning up a chain, right? Like, I mean, in the sense that there is no validator bootstrapping to be done. In most cases, right? Like, I mean, if it's let's say like a validity or ZK proven rollup, all you really need is one sequencer and one prover, right? Like, and even that prover can be shared amongst multiple rollups, right? Like, I mean, I'm not saying that you should totally run only single sequencer rollups. Of course, there'll be some decentralization. I'm just saying that if you want to do a monolithic chain today, right? Like, look at the Cosmos ecosystem, right? Like, I mean, it takes immense effort to kind of like bootstrap this validator set of 100, for example. You have to set up a token, you have to ensure it as a value. There's a lot of validator bootstrapping cost, right? Like, which has to be paid by someone, right? Like, I mean, nothing comes for free, right? Like, I mean, so basically, the role of construction changes that dynamic in the sense that like it borrows of the security of the base layer, and the cost of spinning up that chain or roll up that is pretty low, and that leads to like a lot of potential for experimentation, right? Like, I mean, if you have like a monolithic L1, right? Like, I mean, let's see Ethereum, for example, right? Like, it's very hard to make any changes to Ethereum, right? Like, I mean, let's say, like there's this OP stack, I think, fork called OP Clave, for example, which added a few precompiles because, like, I mean, there are some other chains that added, like some custom functionality, for example. I mean, so essentially, what I'm trying to say is the base layer necessarily has to be, like it can't be changing all the time, right? Like, I mean, it needs to have some sort of ossification over time. And so, the roll-up construct is primarily this whole framework by which, we can add arbitrary new experimentation things, right? Like, I mean, arbitrary VMs, arbitrary authentication or access mechanisms, or like state models, whatever experimentation you want to do. If you want to do it with a custom L1 chain, that's very, you can do it. It's just too expensive. Here, like it just doesn't cost much.
And that's again specifically because you have to spin up your own data availability layer within the Cosmos or kind of like subnet ecosystem,
Yeah.
and that is not shared. And it allows you to experiment with, as you mentioned, the different virtual machines, kind of customize that stack and play around with kind of different compute, which I do think is interesting as well. I'm kind of partial to parallelization. I think it's going to definitely help kind of some of the scalability fronts, but perhaps a different conversation. No, and I do think in general the modular kind of versus integrated stack is still a little misunderstood. And that having these conversations definitely help kind of progress the industry and push it forward. They definitely play out on the timeline, and it's a little bit hard to kind of parse apart them. So I appreciate kind of the long form content where we can kind of go through them. But particularly maybe jumping back to what is kind of happening in the Ethereum land, particularly around Base. Ethereum today as a data availability layer is really not doing that much data. And that's partly by design, but also kind of limits some of the scalability fronts. As you mentioned early in the podcast, I believe it was like 80 to 90% of Ethereum's or of layer two's costs is settling to Ethereum because it has limited amount of data availability. Once EIP 4844 introduced, it kind of doubles or triples the amount of bandwidth approximately that Ethereum will have. But I think over the long term, you'll still need to scale. You'll have dank sharding and then other ecosystems such as yourself and what you're building at Avail that will really kind of maximize the throughput that you have at the base layer. Can you kind of talk about, in the long term, where do you kind of see the role of these data availability layers? Is it to kind of maximize the amount of throughput at the base layer? Is maybe 100 megabytes enough? Do you need 1 gigabyte per second? Is it 10 gigabytes, 100? Like, where do you see it going long term?
Yeah, I mean, so basically, of course, the function of the base DA layer itself is to maximize DA. I mean, the actual throughput will depend upon, like how much block space demand is there, right? Like, I mean, and that all depends on, like what kind of apps really get built and what kind of, like bandwidth is really required, right? Like, but essentially the architecture that, like we are optimizing for at Avail, that kind of, allows for, like expansion of that, right? Like that DA throughput, right? Like, in
And do you think
general,
it mirrors, sorry to jump in, do you think it mirrors the early days of the internet? I often find this analogy a little bit overused, but I find it helpful. And so I kind of always revert back to it, where you had kind of 56K modems. You had a limited application set that you could ultimately build upon. Then broadband came, it unlocked a bigger sandbox for engineers. And then you got to fiber optics. And then all of a sudden you could stream 4K gaming on someone else's computer in real time with very low latency. So in that kind of analogy, do you kind of see blockchains playing similar in regards to their progress. Where today, kind of Ethereum's bandwidth and data availability is relatively limited. It will kind of expand to like broadband with full dank sharding, but then there will be other solutions such as Polygon Avail, apologies, that will have really kind of that fiber optics connection where you're targeting hundreds of megabytes, gigabytes in the future that ultimately expand what engineers can build.
No, absolutely. I mean, see, basically every kind of major computing evolution starts out like that, right? Like, I mean, as you rightly said, right? Like, I mean, we started with like 56 kb lines, like on top of the telephone network, for example, and so on, right? Like, I mean, in general, I like to use example in terms of mobile app evolution, right? Like, I mean, so when the first mobile OSs were made, right, like when the first one of phones came, right, like, I mean, it was just too early to envision some of these apps, right? Like, I mean, let's say something like an Instagram or like something like an Uber, for example, right? Like, it wasn't built in the first few years, right? Like, it took a lot of time for people to kind of like put that intuition together in the sense that okay, I have a camera that can go anywhere. Like why don't we use it to like click photos, for example, and post it to our social circle, for example, or we have now a GPS. Like on our device that we can carry on our phone. Why can't we apply it to the problem of finding a cab? Like, so I mean, I remember the first app that I made on one of the early mobile OSs long back was was this like, can I take this paper form that I fill and like put it on the mobile so that like, so I don't have to fill paper forms and then like input it to the desktop, for example, right? I mean, initially like the kind of apps that get built are limited by the kind of infra that is available, right? Like, and as you go forward, right? Like, I mean, in India, for example, right? Like, for a long time, like internet bandwidth wasn't that available to a lot of people. But there just came this player called Geo, like who kind of started giving data almost for free. Like, I mean, like a few dollars per month, for example, right? Like, and till that time, Indians, India is a big country, and they didn't have, like they used to spend their like data bandwidth very judiciously, right? Like on the only they used to do put cellular data off, for example, not to waste bandwidth and so on, right? Like, I mean, but once Geo came in and gave this like data almost for free, the YouTube usage just grew exponentially over time. In general, the video and like now it has come to a part where there is this whole content creation industry that has sprung, and like there's a lot of domestic consumption, for example, and so on, right? Like, I mean, in general, what I'm trying to say is that of course apps are influenced by infra. So with the kind of infra that early on is there, you will see apps that will fit to that infra. If we kind of expand that infra, like that, the kind of apps that change. And like that, it brings an interesting point is like that's why I also have been mentioning about experimentation with different like this execution environments, but also with how to access the blockchain. Right? Like today, for example, you have these standard ways that has somehow become standard, right? Like, I mean, but there is no reason why you cannot have rollups doing very arbitrary access mechanisms, right? Like, I mean, you could have some rollups doing a very gated API access token kind of an approach, for example. I mean, there's nothing to stop it doing it, right? Like, I mean, state models, for example, you don't have to conform to the EVM state model or the Solana state model, right? Like, I mean, it can be arbitrary, right? Like, I mean, in normal web or mobile application development, what most developers start with, right, like is they write the data model first, like they will define the schema, database schema first, and then go and write the business logic, right? Like in current blockchain implementations, like what happens is because there's a global state model that everyone has to adhere to. People have to tailor their data model to the global state model and then figure out ways and means to write and read and write to it, right? Like, and that's why you see all this complex, I've written, like at least couple of indexers, EVM indexers, like which are very painful kind of to write and maintain. For example, you have to run complicated, like transaction, like relay infra. You have to do, like RPC. You have to have hosted RPC nodes because no one can run a full node on their infra now. So, I mean, see, everything is well and good, like when we discuss about monolithic blockchains, but you cannot deny the fact that application developers have to manage a lot of infra, like managing this global shared state model, right? And it's not a very easy thing to do. I mean, and unless we move the needle or like reduce the friction for application developers by coming up with infra that kind of helps them to do more experimentation faster, cheaper, we are going to end up with the same old apps being developed.
Yeah, I mean, to your point, having kind of a preordained data model kind of inscribed into an execution environment definitely forces engineers to is rather opinionated in kind of prescribing to engineers a type of way to build. I think there are some pros to that, just making kind of the social coordination between developers rather easy because you have a single unified interface of one data standard and everybody kind of complies to it, versus kind of the modular approach where ultimately you do get much more flexibility. But with that flexibility can also come kind of the social coordination of trying to go from one data model to another and kind of comparing and contrasting some of the opinionated pieces with kind of prescribing the data model versus maybe a less unopinionated with different execution environments. But at that kind of comes the social coordination piece. So it is interesting. It's not necessarily a correct way. It's, again, just like how you kind of go and evaluate those different trade-offs.
Yeah, no. So even if you look at the web, right? Like, I mean, there are standards that, apply to everyone, right? Like, let's say, like the HTTP, SSL standard or, like things like that, right? Like, I mean, there's a standard way to do it, right? Like, but, like things like, cross app messaging, right? Like, I mean, REST, for example, right? Like web apps, mobile apps use REST, right? Like, I mean, now, if you were to prescribe like a standard format for every app on the internet to interact with other apps, it's going to be unnecessarily restricted, for example, right? Like, and that's why. So it's useful to see the evolution of like how the web has developed, right? Like there are standards, like which most apps have to adhere to for some areas, but other areas where there's a lot more flexibility into how you define those interfaces. And I see the same thing happening here as well. Right? Like, I mean, now the thing is again, like, how restrictive do you make the standard interfaces, right? Like, I mean, and what level do they need to be done, right? Like, do they need to be done at the level of the state model that you need to do? Like I don't, like agree with that, for example. So in general, what I'm trying to say is it's not like modular is, like Wild West. Like, everything, there's no standardization at all, right? Like there will be standardizations going forward, but there is enough room for flexibility that, you can actually do the things that you need to do. Right? Like that, I think that's roughly my thought on that.
So the true standardization, at least today, is the agreed upon data availability layer, which kind of unifies the different execution environments on top. And then it's kind of your belief that over time, even though you may have different execution environments, different layer twos, those will have standards across them that will allow them to kind of communicate, even though they are not necessarily equivalent, or because they have that additional flexibility, they may not map one-to-one kind of the communication standards today, but over time they will.
Yeah. And actually, one thing we are missing also from this whole debate is also the rise of, especially on the ZK or validity proven side, right? Like recursive ZK proofs or recursive validity proofs, right? Like, And like actually, we are working with a variety of teams, not only on EVM, ZK EVM, but also on non EVM VMs. Yeah, like RIS0, for example, and others. And all of these great ZK teams are basically, like they have recursion built into their proving system. Now, why am I mentioning this? Is because at some point in time, right? Like, I mean, of course, these proving systems are able to do recursive proof aggregation with proofs of the same proving system. And so, like what that practically means is if you have rollups, like let's say 10 different or 100 different rollups working on risk zero, you will be at some point in time be able to aggregate proofs from these rollups. And so essentially get proofs rolled up into this. And so you can have trust minimized messaging between these, right? Like, and so there's some sort of standard that will need to be applied. Now I'm referring to, let's say, proofs from one proving system, but my hope is that in the next year or two, you will see the first instances of proof aggregation across two proving systems. Some of these, I mean, maybe it'll be like the ones that are, like similar in implementation. For example, like I've already seen code from like the Maiden VM proof being verified and the Cairo VM, for example. So things like that, right? Like now, when that happens, right, like you will see some sort of a like some standards emerging from that, because the trust parameter itself is being solved, because I mean, of course, we assume that all these ZKVM systems have been audited and like run properly. But if that were to be considered true, and if we are able to compose proofs, then like that allows for a very rich variety of messaging, and then like standards can be pretty quickly coordinated.
And so, and just to confirm, when you're kind of talking about the aggregations of different proofs, are you kind of talking about like a shared sequencer, or that people will ultimately, excuse me, settle multiple different rollups to a kind of individual or shared sequencer that allows kind of that aggregation of numerous different rollups and then posting it, kind of doing the recursive proof, and then that can be proved to somewhere else?
Yeah, I mean, you don't really need a shared sequencer to do that. Essentially, see, that's one of the benefits of like doing a roll up on, let's say, something like, I mean, on Avail or any other shared DA layer, right? Like, I mean, the roll up data is already being posted to Avail or the base layer, for example, right? Like, and so you have all the roll up data already being there, right? Like, and so now when you combine this DA, shared DA, with like aggregated proofs from all these rollups, right? Like, so what this shared DA gives you is access to availability of all the transactions, the ordered set of transactions, and the proof really gives you the like very verified like execution correctness. And so essentially, like this construction. Now you could have like a shared sequencer kind of a construction, but I mean, you do it without that as well. In fact, at Avail, we are building this middleware called Nexus on top of Avail, which like will provide proof aggregation as a service as well. And so and that's why we are like working with a lot of these newer ZKVMs for that.
Interesting. And so maybe for the listeners just who are following along, we're kind of talking about the different execution environments when you separate kind of in the modular stack. So you have the data availability layer, which Avail is ultimately working on, trying to maximize the data availability bandwidth at Avail specifically, which allows various types of rollups, possibly hundreds or thousands in the future. Those will create proofs and settle that to the data availability layer. And that is kind of, you can either have the kind of limitation being on the compute side or the bandwidth side, but both ultimately have to be scaled to increase the overall throughput of the ecosystem. Once it is on Avail, then you kind of have the ability to kind of aggregate these shared proofs, because the data availability layer is the thing that's unifying all the different layer twos, correct?
Yes, you can say so.
Interesting. So in this world, I mean, maybe getting back to Avail and what you're doing, you've stated that today approximately blocks are every 20 seconds. You're doing 2 megabyte blocks. You've tested blocks up to 128 megabytes. Kind of with that analogy of going from dial-up broadband to fiber optics, do you kind of see a world where you will ever need to stop increasing kind of block size? Or do you think kind of human demand is insatiable? Will humans always want more, always want it faster, or at some point will it be good enough?
Yeah, I mean, of course, I mean, I would like to say that, like we would be happy to, kind of scale this till the laws of physics hold us back, right? Like, but we also have to be practical in the sense that, I mean, the kind of apps or the bandwidth that is there, right? Like that also needs to change a lot. So it's not only about increasing DA bandwidth, it's also about essentially helping build infra. And this is why I refer to like both DA and like these ZK VMs. I mean, I have nothing against optimistic systems; they are also pretty good. But the ZK or validity proof system driven execution environments unlock a whole new like developer experience, and essentially so I think one of the first goals is like quickly finish this infra so that like we can have more app developers build more apps. So I mean, I was talking to someone yesterday, and like we were talking about these roll-ups on top of Avail as chains. So I mentioned that like right now these seem like chains. At some point in time, right? Like these will be viewed as apps, right? Like I mean, essentially, like you have some, like let's say there's this company called Stacker, for example, which is building a app specific rollup, right? Like which doesn't even have a VM, right? Like it has the state transition function encoded in its execution, right? Like I mean, that's what it runs, right? Like in general, and you can define the state model. And what I'm particularly bullish on is these more lightweight app chains with very custom state transition functions or very light VMs, like basically, and with custom state models. And essentially, the end goal for that is to create the infra in such a way that, like the app chain orchestration itself is all abstracted away. And what the app developer really comes to this part is, with their business logic and with their state model, which is what, let's say, monolithic chains with, let's say, on the EVM, for example, on Ethereum, or let's say Solana, for example, provide today at the moment, right? Like what they provide is a hosted service, right? Like, I mean, validators run the nodes, for example, but from the applicant developer point of view, it's a hosted service. You don't have to worry about who runs the validator node, etc. And so what we really want to do at some is basically deploying these app chains as simple as deploying a smart contract on a monolithic chain, right? Like, and essentially once we reach there, then like basically I think that will be the unlock where we will have lots of app devs, kind of starting experimenting with all this new kind of functionality that is available, right? Like, so I think one thing which we have been missing a lot in the blockchain industry is also how to. So what we as an industry we are doing is, like we're building systems, and it's like I mean, I don't want to say like a walled garden, but essentially it's a new world, right? Like, and people have to come into this world to use it, right? Like, and there's no really very great interface between, let's say, like a mobile app or a web app sitting outside of this. You have to buy tokens to get into blockchain, for example, and it's a lot of things going on. But at the heart of blockchain is like what does really provide? Of course, it provides a lot of things, but I think the most important thing it provides is like trustless compute, right? Like, or verifiable compute, right? Like, I mean, and you see a lot of industries out there, right? Like basically, like things like escrow. I mean, I don't know if it's not, it might not be a very big problem in Western countries, but in developing countries, very simple things like an escrow are a huge issue, right? Like because the level of trust is pretty low. And so there are escrow companies that are doing millions and billions of volume every day. And their stack is they have a bank account that they have a license for, and they escrow the funds in the bank account and like give it out when it is due. If you kind of think of it, escrow is a default in smart contracts. Like the thing is we haven't figured out a good way for people to access this functionality, for example, right? Like sorry to get into this long-winded this thing, but like in general, like I would like to say yes, we can scale this as much as we want, but there has to be like a lot of improvements on how we get more app developers to enter this space.
100%. As we've kind of gone down the rabbit hole, infrastructure does enable more interesting primitives. And I think as more interesting primitives get built, it will cause us to reflect and look at the infrastructure again. And we'll kind of do this over and over and until we, maybe forever, we'll see where we ultimately get to. One kind of criticism, or not criticism, pushback that I hear often is that the modular ecosystem, or in terms of by enabling one application per chain, you're kind of fragmenting or siloing that application to a specific instance or its own world, where we're kind of recreating some of the gardens that currently exist. Instead of having a kind of shared state, you have a individual state, and that can be reflected across hundreds or thousands of individual applications if they each choose to build their own. How would you kind of answer, or what kind of data points would you give to say, look, no, you should be making your applications in kind of their own siloed instance, and it's less about shared state, it's more about controlling the stack that and the flexibility that the modular stack allows you to utilize?
Yeah, no, I think so. This debate is, like mostly around synchronous composability and, asynchronous composability, as I like to put it, right? Like, I mean, in general, if you look at like anything on the web or mobile or like in general in internet infra out there, right? Like, I mean, if you look at let's say if you are buying something on Amazon, when you kind of want to buy an item, right? Like, I mean, it sends a request asynchronously to like a Visa microservice that kind of gives you the payment page, for example. When you enter the payment, like Visa receives that data, then sends an asynchronous message to Amazon saying, like the payment has been made. And then, Amazon then basically sends a microservice call to its logistics provider, which then kind of starts shipping, for example, right? Like, I mean, and all of this happens in a matter of seconds, right? Like, I mean, basically, I think there is a requirement for synchronous messaging, because I think it's also that opinion is biased in the way the blockchains have evolved, right? Like, I mean, blockchains have evolved in this monolithic kind of an environment, right? Like, Ethereum is a smart contract platform where you can host multiple apps, and because they have the way it is architected, you are able to message between contracts, and similarly with other blockchains as well. But there is, if you go back to the example that I gave, right? Like, I mean, you can treat the entire internet as one big whole computer, and everyone is synchronously talking to each other. But in reality, the internet scaled because you can, create this different microservices which can, like asynchronous talk to each other. Latency is not an issue at all, right? Like, I mean, you hardly notice the microservice call being made to a Visa, for example, from Amazon, or I mean, it's pretty fast, right? Like, I mean, and that's what matters, right? Like, I mean, and in this whole thing about on blockchain, right? Like, of course, synchronous composability is important. It allows for, like, let's say, especially in DeFi, for example, it has allowed for, I would say, innovation on top, right? Like, I mean, there's been apps being built on top of Uniswap, or, like, so So, but there is of course benefit to that. But I would say there are a lot of use cases that don't really need synchronous composability, right? Like I mean, asynchronous is fine for a lot of use cases. And if we go to this modular app chain thesis, and we see like a lot of these rollups running, and as I already said, right, like with proof aggregation, for example, we should be able to quickly allow asynchronous messaging, and I would say that is fine for a lot of use cases, and because it gives you like a lot of flexibility on like how you give access to users, how you handle users, so on, right? Like I mean, state contention, etc., etc. So I mean, again, right? Like I mean, there are and in general, right? Like I also want to address in the modular ecosystem doesn't mean that each app roll up on top of, let's say, Avail or any other modular base layer is going to be an application specific chain, right? Like you can actually run an entire SVM Solana virtual machine rollup or an EVM rollup on top of Avail, for example. Like, and there are teams that are trying to do that right now. And so those who want that synchronous composability can use that rollup. Same way someone uses Arbitrum or a Polygon ZK EVM for now, right? Like, and like if you want to message application on another rollup, then you do a asynchronous call, right? Like, I mean, so yeah.
Yeah, no, it is interesting, and I think like as we've kind of talked throughout this podcast, a lot of it is just ultimately the trade-offs that you decide to enable. Necessarily, there's lots of engineering choices that kind of go into these things versus the different stacks, and it's not. I always say you can't really remove these kind of issues. You can kind of just move them around per se. It's can't really eliminate them 100%. I think what I've tried to focus on is kind of the core raw ingredients of blockchains, which in my opinion are that data availability layer, which is bandwidth, and then on the execution side, which is compute. And I think you can either kind of do like the sharded architecture, or you can have like a single unified data availability layer. You can do multiple different rollups, or you can do like a large kind of machine that does the execution alone. But you still have to scale both bandwidth and compute. Those are kind of like the non-negotiable items.
Absolutely.
So it is interesting. I think the industry is young, and I'm excited, quite frankly, about that we are kind of in our quote unquote dial up phase, and we're graduating. We're going from dial up to broadband in terms of blockchains and the amount of data availability that blockchains are really going to lock, specifically around what your team is building at Avail, granting and unlocking the true power of more data availability and what that will allow engineers to ultimately build with different applications, I think is only yet to come, and I'm excited for that future.
Yeah, absolutely. We're also kind of we've been working on this since late 2020, and like it's finally everything is coming into play, and yeah, we are hoping to ship quickly as get into production as quickly as possible. But I'm absolutely very bullish on like what these can unlock for the ecosystem.
In terms of kind of the broader ecosystem, there are various teams working on different data availability layers, whether that's Ethereum itself, whether that's Celestia, I guess you could call maybe even Sui or Solana or Aptos data availability as layers as well, maybe slightly more opinionated in the data stack, but still scaling the data availability at the bandwidth. In terms of kind of your arguments for why engineers should pick Avail over these other ecosystems, could you maybe elaborate on that? Because I think now we're kind of going from we were resource constrained to lots of teams have started to unlock these resources. And now it's really about, all right, I need engineers to build useful applications on my tech stack. And now they have more options than ever. What would your kind of recruitment be to the engineers to have them build on like the Polygon or the Avail stack?
Yeah, I mean, so basically, so Avail and of course Celestia as well. Like I would say, we are slightly different breed of players. Where I think our main customers in general are like initially at least roll up developers, right? Like I mean, and so essentially the app developers and they then interface with app developers in general, right? Like so we provide a service to rollups, whether it be app specific rollups, whether it be shared, like rollups, for example. And that's what we focus on. Of course, I mean, there's a bunch of stuff that we are planning to do with the application developers. But for now, our strategy is to kind of work with the rollup providers, whether these be Ethereum L2's teams, for example, or the more newer sovereign rollup stack players, for example. But essentially, we kind of work with our partners to kind of interface with the application developers, and of course, we help the rollup developers kind of refine the infra that they want from us in general. We also collaborate with a lot of these teams to do the actual work, right? Like I mean, we are working with, let's say, the Madara team from Starkware to get Avail into to the Starkware stack, for example. We are starting to work with a couple of other L2 teams, the bigger ones, for example, to get Avail into their stack. So essentially, initially we like to answer your question, the application developer really doesn't need to know about the base layer, like to take a decision, right? Like because most of their choices are defined by the rollup configuration, right? Like I mean, so if someone is building an SVM rollup on top of Avail, then most of these choices are already taken by the SVM rollup, right? Like the application developer just needs to deploy the Solana contract, or let's say we are doing an EVM rollup, or we are doing an app specific rollup, right? Like so, these are opinionated choices made by the rollup designer, and essentially all of them depend upon Avail. So we are more like a backend infra play, more than a very applications play. The one place where we want to get into front and center of the application developers, of course, along with our partners, is once ZK, the lightweight ZK app chain kind of construct really becomes mature. That is a few months away. And once that is there, then you'll be able to come up with this new kind of construction where like which hopefully makes the app chain construct, like I mean, just bring your business logic and state model and put it into this infra kind of a construction, right? Like I mean, so there we will kind of focus more there. But for now, I mean, we work very closely with our partners to do this. Does that make sense?
Yeah, no, definitely does. I think, yeah, the roll up landscape is interesting. It's definitely unfolding quickly. You guys are obviously expanding the bandwidth side on the data availability layer. You're kind of, it's up to the layer twos really to expand now the different execution environments and scale the compute side. And as both of those scale, the data availability side, it allows for more scale on the compute side, and you can continue to scale together, allowing application engineers to build more interesting apps.
Yep.
In terms of, I mean, maybe kind of as we're wrapping it up, we kind of talked about just increasing raw block size and that really being one of the limitations to scaling overall data availability. We kind of talked about Avail going from 2 megabyte blocks to 128 megabyte blocks. In that, you're also kind of mentioned that you're doing 20-second block times. Do you see that block times kind of, can it decrease over time, or do you have like any future vision of kind of trying to shrink those or even maybe possibly expand them? Any thoughts or considerations around playing with block times?
Yeah, I mean, so basically, when we think about like the block time for a base layer, so basically it's again optimization, right? Like I mean, what we want to optimize for at the base layer is one of the things is, of course, like some amount of decentralization, right? Like we want decentralization at the base layer to be good, right? Like, and that necessitates a wider set of validators, and that also means that like we need to kind of ensure there is enough time for validators to reach consensus, finality, for example, and so on, right? Like now it doesn't matter that much to users because most, I mean, there are two types of rollups that are possible. There's something called base rollups. There's something called sequencer run rollups. I mean, it totally depends on who does the sequencing and where. And most implementations, for the purpose of practicality, are going to run sequencers with second block times or maybe millisecond level block times, or like something like that, which provides primarily the primary part of the user experience for most users, right? Like now the block time on the base layer really lends itself to the actual finality, right? Like there's a soft finality element, there's a like a hard finality element, and so within that constraint, I think like a block time of 20 seconds is pretty great, because the consensus that we use, like Grandpa Bay, for example, like it is a hybrid ledger, and mostly like it finality is achieved in two blocks. Sometimes finality might be delayed, but block, it's a hybrid ledger. So we have Babe do the block production and Grandpa do the block finality. And so block production always goes on. Finality in most of the cases will be, like pretty quick. In some cases, it might get delayed. But essentially, what I'm trying to take up from this is on the user side, like the soft finality is provided by the sequencer or set, for example, and that is already, for example, on all the rollups that you see on Ethereum, it's mostly either a second, 2 seconds, or in some cases milliseconds, right? Like so, so we don't foresee bringing the block time down on the base layer, because it's really not necessary. Also gives us the flexibility to increase more block size as well, more than what we have benchmarked, like 128 MB. We can go much farther than that as well.
So, and maybe just so I can re-articulate it once more, the soft finality provided by the sequencer will give the users kind of enough confirmation, especially from the user experience, that the finality on the layer one or ultimately Avail can have the longer block times because it's not directly affecting the user experience, in your opinion.
Yes, yes.
Gotcha. Cool.
I mean,
well,
and this also has to go in conjunction with like again, right? Like I mean, you also see this, all these ZK rollups now coming up, right? Like, and finality, like, so there are two elements, right? Like there's a finality element and there's an execution correctness element, right? Like so the proof generation, right? Like for a ZK rollup, for example, right? Like so as soon as you have the proof generated, you know that the batch of transactions, the execution was correct, right? Like now you have to rely on the order of the transaction, the finality of the order of the transactions that the DA layer, like gives, for example. And so a combination of this, like you can make enough configuration or structure changes, and which can provide the best UX to users.
100%. Maybe wrapping up the podcast, we've gone through a lot, kind of talking about data availability's role within blockchains, how you ultimately need to scale the data bandwidth at the data availability layer, which allows you to further scale the execution environments or the compute within kind of different execution environments, how those are kind of intertwined. But once you scale both, you can ultimately allow engineers to build more interesting applications over time. And really, the Avail thesis is by creating these modular ecosystems, it allows developers the greater flexibility to really choose the things specific to them and their applications. It maybe kind of wrapping up, like as looking towards like the end of the year or even 2024, are there anything that you are specifically excited for that the Avail team is ultimately working on, or even outside of the Avail team? I know we've talked about zero knowledge and Validium type rollups. Are there anything particular that maybe outside of those categories that you were looking forward to?
No, absolutely. I think, of course, we are trying to get that shipped from within Avail, but other teams might also be working on it, right? Like, but of course, there's a ton of other things that I'm excited on, including Verdiums and optimistic chains and L3 chains and such. But one thing I'm pretty interested in is because we have this data already sampling unlock, and what we are doing is coupling this DA verification, like our light clients can do data sampling and can do DA verification. We are coupling that with a proof, a validity proof verifier, uh, and embedding it into besides the light client, so that, and we are trying to put this in a user wallet. So we are already working with like a couple of wallet teams to embed the light client into the wallet, but also the proof verifier. And so at some point in time, we will have, hopefully soon, we will have a wallet that has very cheap verification of data, efficient verification of data, but also, efficient verification of state. And I think once we have that layer up and running, I think that will unlock, like a bunch of use cases that, like we are excited on. So that is one thing I'm certainly very excited on.
Amazing. Well, we'll wrap it there. Thank you so much for joining me. Really appreciate your time. Excited to hear you kind of share your vision for kind of the modular stack, increasing the data availability that the entire ecosystem really has access to. I truly am aligned with you there that we need more bandwidth and we need more compute. We need to let engineers allow them to build more interesting applications, and those raw ingredients of bandwidth compute are the things that we really need to solve for.
For sure.
Amazing. Well, thank you again. Appreciate you coming on the podcast, and wish you and the team all the best.